m equals n equals r. That's the invertible case. Okay. What do we do with a system of equations when we can't solve it? This is probably the main application in 1806. So you've seen this problem before. What do we do if ax equal b has no solution? So typically b would be a vector of measurements, like we're tracking a satellite and we get some measurements, and often we get too many measurements, and of course there's a little noise in them, and a little noise means that we can't solve the equations. That maybe the case everybody knows is where this equation is like expressing a straight line going through the data points. So the famous example of these squares is fit a straight line. A straight line to the b's, to B1, B2. We've got m measurements. We've got m measurements. The physics or the mechanics of the problem is pretty well linear, but of course there's noise. And the straight line only has 2 degrees of freedom. So we're going to have only 2 columns in our matrix. A will be only 2 columns with many rows, highly rectangular. So fit a straight line, let me call that line Cx plus D.